Hello, I'm Anna Mackay, and this video is on relations and functions. So, what is a relation? Well, what's a relationship? Having a think about the connection that might mean between two people or groups of things. Mathematically, it's any set of points connecting two variables, so two unknowns, and what's the connection between them? Any set of points. So it's any set of points, what we mean here on the Cartesian plane. All right, so here's an example of a relation. Straight line graphs are relations, where the equation of that would be y equals x plus 2. So that's the connection between the sets of points. So for any x value that you're going to get, how to work out the relation that it has with the y value, you add on 2. Another example is a relation here, and the equation for this relation is x equals y squared. Whether or not these are functions we will come to discuss, but they're definitely relations. Another example, here the set of all points where x is greater than 0 and y is greater than 0. So that's referring to every point in quadrant 1 of the Cartesian plane. That is a relation. Is it a function? Find out. Stay tuned. The set of points here on this Cartesian plane, that would be a relation. Okay, another way of thinking about this sometimes is thinking of a mapping diagram. So here's a set of x coordinates that we have and leading to a set of y coordinates. Noticing how many are in the x, how many are in the y, and what that could imply. I wonder if you could imagine what type of graph it could be where two different x values head towards one y value, what type of shape that might be. It's not so relevant at this moment in time, just while we're discussing mapping diagrams. Here's that set of coordinates that would come out to be. Now, so that was a relation. What defines a function? A function is a relation in which no 2 points have the same x coordinate. Very specific there. Or first component, as is sometimes called. So in other words, each value of x has at most one corresponding y value. Not necessarily the flip side of that, you could have more than one y value. Sorry, you know what I'm trying to say here. But so the x has at most one y value. Let's go on to some examples. So the mapping test that we could do for functions here. So what is our condition? We have at most one y value. Does that match here? Here's an x value, it's got a y value. Here's an x value, 2, its y value is 3. X value of 5, y value of 3. I bet what you're wondering is, but hang on, that 3 has doubled up. Is that allowed? Yes, that is allowed because each x value, thinking about each individual x1 here, that has one corresponding y value. Let's have a look at an example where there's the double up of the x. Well, just to clarify this one, so each value of x maps to only one value of y, so that relation is a function. Let's have a think about this one. Each x value has at most one y. So this -7 to -3, tick, that meets our conditions. But this one here, the -2, it has two options that it could go to, -3 and 0. So that means the -2 has two options of y values. That does not meet our condition for a function, so therefore it's not. So as we say, -2 maps to more than one value of y, so this relation is not a function. If ever you're asked to justify why a relation is not a function, I guess from a mapping test or just sort of algebraically, that's an example that you would give to justify that which value maps to more than one y value. An example here, there's a double up again. This 8 has two x values. Does that meet our condition? Each x value has at most one y value. So our x value of 1 goes to 8, so that's fine. and x value of 3 goes to 8. So they've each only got one that they map to, so we're fine, as I said. The algebraic test. Suppose a relation is given as an equation. If the substitution of any value of x results in at most one value of y, then the relation is a function. Let's have a look at that. What about y equals 3x take 1? So what you could do is you could substitute in any value of x, and you want at most one value of y. Pick a value for x in your head. I'm going to pick 4. So if x is equal to 4 and we substitute that in, I end up with y is equal to 11. So we have at most one value of y, so that must be a function. But what about this one? X is equal to y squared. Well, let's substitute in a value of x. First of all, I'm going to rearrange it to write it this way around. Oh, no, didn't have to do that. But anyway, if x was equal to 4, again, like I used with the other one, y is equal, well, what is y equal to? Y squared is equal to 4. So therefore, y must be equal to the square root of 4. And we know that we can have two values of that. So we have plus or minus 2. So therefore, we've got two possible values of y. So that means this relation is not a function. And the classic is called the vertical line test for functions. So that's done visually. The definition here, if we were to draw vertical lines on the graph, so vertical lines like this, cutting through the graph. If each line cuts the graph at most once, then we have a function. If at least one line cuts the graph more than once, then the relation is not a function. Let's have a look at some examples to make this really clear. Which of the following relations are functions? So they are all relations, but which are functions? So taking A there, looking at that curve, if you were to draw vertical lines through that graph at any or every point, how many times will that vertical line, those individual vertical lines, cut through the graph? Once, at any point in time. So if you were to draw lines on like this, it's only going to cut through once. So that would be a function. The second one, so probably a cubic here. If we were to draw vertical lines through, it's only cutting through once. So that would be a function as well. But what about this one here? So we've got not cutting through at all here, but that's okay. But here, we've cut through twice at this point and this point here, which means we would have two y values for that value of x, which means it's not a function. Just confirming this more neatly, you can see some vertical line tests there on your screen. And answering those, A and B are functions, C is not. Okay, so that's the end of this video. If you liked it, give it the thumbs up and subscribe to the channel. And the next video in this series is function notation. Thank you.